I have a really fun one here. I have been working on a little touchscreen device with a Raspberry Pi that I am using as a Home Assistant voice assistant satellite. So this is either a screen or just a speaker and microphone if that's all you want in any room with a Home Assistant setup, and that is for home automation. The voice assistant that is set up as a configurable item in Home Assistant requires several things in kind of an ecosystem of components, and it has been developed during the year of voice for the Home Assistant project, which I think turned into a little bit more than a year, but we are very, very glad to have it because it is cool. So I'm going to go into the components and the setup and the likely problems that you will encounter trying to set it up. So my my bashing my head against the wall should hopefully be something that you can skip. There is a GitHub repository, which I will have down in the description, and you can either follow along with the video or just read the document. Depends on kind of tech familiarity. So we're really going to be focusing on setting up the satellite itself, the little device that will be on the periphery. However, I do need to cover at least what components have to be set up in on your Home Assistant server first. But the rest will all be kind of hands-on, and we shall see what the end result looks like, which is a lot of fun. We will start with how we set things up in Home Assistant. The first thing is something called the Wyoming protocol. And this is a very thin layer of communication that the Home Assistant project set up during the year of voice. And it allows all the various components, such as the listening to the wake word, which is actually usually best handled on the device itself and not part of the Wyoming protocol, but then components that reside on the satellite. There's a project called Wyoming Satellite, in fact, that we will install that manages the coordination between when you start speaking, turning that audio that you presented during your speech into text, giving that text either to Home Assistant because it matches an intent that is a type of a quick automation, or handing the resulting text off to an LLM. All of these things, all of these components can be hosted by you in your own setup. Even with only CPU, I do have a GPU machine that I run LLMs on, but you can use any combination of local hosting and cloud components for any of these things. Let me fix the wrapping here. Okay, so that's all that you have there. The way it looks in Home Assistant itself, let's see if I can get there. I have Home Assistant running here. You will look at settings and then devices and services to look at your integrations. The integration that you will install for this is called Wyoming Protocol. And as you can see, I have one or two satellites defined. I'm going to get rid of, let's say, the kitchen satellite, and we'll set that one up ourselves. We'll set up a new one. Piper, which is text to speech. We'll get into all these pieces. Okay. Next thing is Open Wakeword. This is not something that you install on your server, though. Although you could have your Home Assistant server listening to the wake word on all your peripheral devices, on all your satellites. However, seems a really, really bad idea because all of those devices would be constantly streaming audio for your Home Assistant server to try to find an instance of the wake word. So When you install that, there's a whole project for that, but it goes in the satellite itself, and its entire purpose is to pass butter or to listen to the wake word for that. So it spends its entire existence listening to audio from the microphone and hoping to eventually discover the wake word. Then there is the Wyoming Satellite, again, not installed on your server, but something that will announce itself to the server, and you'll have one or more satellites, as you saw in my setup. And that is something that coordinates between all the different components. It says once a wake word has been detected, the local wake word detection notifies that satellite service. The satellite services then opens the microphone, listens for speech, and you can have it either be relaxed or aggressive, in which case it might cut you off as soon as you pause in your speaking. So that's not very great. And then it will take that audio and push it to the next step in the integration, however that's defined in your setup, which will decode your audio into text. That text then goes back to Wyoming Satellite. It's passed on to Home Assistant, which will decide whether it can already handle that because it's one of the known phrases that it uses in its intent system, and or whether it should be passed to the LLM that you define in one or more of your voice assistant pipelines. The LLM then returns a couple of things. One is a set of instructions to control devices if you've asked to turn off the lights or play music somewhere, for example. And the other is conversational text, which will come back to the satellite, and then the satellite will send it finally to your text-to-speech, get the audio, and play the audio for you on that device. And that entire sequence is then done, and you're back to listening to the open wake word. That was fun, right? So the whisper is the speech-to-text component. It's almost always whisper. There are other ways to convert speech to text, but OpenAI has the whisper models, and it is in fact the only open thing, open sourced from OpenAI, but it is quite excellent. There are small, large models, there are medium models, there are English only, there are multilingual ones. For my purposes, I found that I absolutely have to have a multilingual model, because even if you say, hey, tell me something about Quintana Roo in Yucatan, or or Darmstadt, Germany, or whatever, it's like it has to understand those foreign names and words in order to correctly transcribe it into text. So I need a multilingual model. However, the largest one, large-v3 at this point, can take quite a long time, because even when you hint for the command to not detect language, it still does, and the entire turnaround with all of its care in taking accuracy will delay by 6 or 7 seconds. So I find that unacceptable. So I find kind of a medium approach to use that. And it will depend on whether you have a CPU or GPU as well. Okay, enough there. And that is actually something that you do install in Home Assistant. So when you look at your integrations, I will have an OpenAI conversation integration as well, and a whisper integration, although we don't see that here. And then for the LLM sections, I have some LLM models hosted on my GPU machine, and you could use cloud-based services such as OpenAI. For the text-to-speech portion, you will use Piper if you're self-hosting, which is a marvelous project that you download again from GitHub. and install as an integration in Home Assistant, or you can use Google Translate or 11 Labs. If we go back to my Home Assistant server, we will see 11 Labs and Google Translate text-to-speech. So I have all of those options that I can mix and match at will. And then your voice assistant pipeline configuration, again, when we go into settings and look at voice assistant, you can have one or more pipelines, one or more voice assistants, you can think of it as. I have only one, and then I just play with switching out the components in that one. So in chat, my pipeline is, or my voice assistant is called ChatGPT again. The conversation agent is actually, you can use Home Assistant Cloud. I don't currently subscribe to that. You can use ChatGPT, which uses that OpenAI conversation integration. Or I have Llama 3.2 and Llama 3.1 hosted on my GPU machine using the Ollama framework, which is another integration, the Ollama integration that I have installed. And then you have speech to text, however, whatever you use for that, and text to speech. So in my case, I'm using the Piper library right here, although if we look, I could also use 11 Labs, Google Translate, etc. If I choose one of those, then it will read what voices are available to me. Like with 11 Labs, these are the voices that are available on my account, given my API key that I gave it, on 11 Labs. Or if I choose Piper hosted on Aziraphale, which is my GPU machine, then I have all the voices that Piper provides, including one that I downloaded called GLaDOS, which we will be using. Okay, that is all we're going through. We're going through none of the how-to on installing those integrations and configuring them on Home Assistant for the server side. The rest of it will be dealing with actually creating the satellite. So the first thing we'll want to do is we are going to be installing Raspberry Pi on our Raspberry Pi OS on a Raspberry Pi. I should have probably mentioned that you will also need a Raspberry Pi. Okay, and then we'll go through and show what that looks like. You should have your micro SD memory all ready to go. I have a 64 gigabyte SD card right there. And then on the Pi board, you will have a place to put that. I always miss where that is. So there was one loaded in there already. I'm going to put that away, and we shall burn this new one with a new operating system. So I have that on my USB stick, and we will put that and get that ready to go. So you can, the thing to do, it says here to select, but that's because we are going to use the imager. So actually let's use the imager, which will give us a lot of setup that we'll do to quickly log in to the machine. So to the new satellite. So I will bring up Raspberry Pi Imager. And the steps here to do things are you select your device. I have a Raspberry Pi 4, a 4B in fact. You select your operating system, your OS or your SO as the case may be. And this says it's in cache on my computer already. The software that I'm choosing to download is Debian Bookworm with a GUI on it. So basically you've got the Raspberry Pi desktop, but without, they've also got a larger image with more additional software, things like LibreOffice and things like that. If you're not intending to use it as your as a computer laptop type of thing, then then you would not need all that. So, and then to select storage, I better plug that storage in, I suppose. Let me do that, and sure enough, it shows up. The next step is something that you can choose to do, where you could say, if you want to select, if you want to start with certain settings and configurations, then you can do that. So I'm going to edit what I currently have. This is called DemoPy. That's not a bad name for it. I'll keep it as DemoPy. And then you would put your user and password that you want to set on the device. So that means generally, I think it defaults to a user named Pi. This is an unprivileged user, although an unprivileged user with sudo capability, but still that's typically very good practice. And you can put the password that you want to use. And the same with your wireless network. Now, I have never had good luck with this so far, where it just automatically connects to the wireless as soon as it boots up, because the passphrase is all scrambled, and I have not been able to get that correct yet. And then you will have regional settings if you want them. And then the only service here is SSH on the services tab. You should set up either password or key access to that. And I put in my key. I don't want to show the tab because my private key is currently in there. But that's all there is to that tab. And then whatever options. I don't want to activate telemetry because I'm not sure what telemetry is being sent to whom and all that. So I might be wrong about what that's even about. I haven't even looked into it. So anyway, that's all. All right, and then we are good with that. We've made our edits and adjustments to our configs. So, and this just says, are you quite aware that this will erase everything on this storage card that you have in there? And I say, yes, I am. And it will need sudo access, which is why it asks for a password there. And then this will take some time as it either downloads, or in my case, since it was already cached, goes straight into writing. Then there's a verification step, and then we will be done with that step. So I will come back after that. All right, it has verified, have continued, and we are now ready to pop that out of there, pop that card out of there, and put it in to our machine. And that we will do right again as soon as I can find it. Wow, I found it fast this time. All right, we put that card in, and we will boot this machine up. Let me get it plugged in. All right, and what will happen as it first boots after this card has been imaged is that it takes much longer than it does subsequently on subsequent boots when it's just normal, because it's setting up the file system. It expands to fill the space that you have on your card, in my case 64 gigabytes, and applies the settings and does basically a couple boots before it does the final one. So we will come back when that is done. All right, it has booted. It's beautiful. And as expected, I had problems with the Wi-Fi at first. So I just put it into plugged in Ethernet and got it going that way. I also enabled VNC. So we have both SSH and VNC. So what I indicate here as our next step is that we should look at our SSH credentials and see if that will work. and enable VNC maybe if we want to make use of that. So let's go to, it told me its IP address was 144. And sure enough, there it is. Okay, so from this point on, I'll just grab a terminal over there, and we will use that. Oops, let's run bash here, and let's look at a couple things. We're running straight Debian, so it says Raspberry Pi OS, but it's really Debian, but with certain packages installed and drivers that configured properly for Raspberry Pi usage. And then also, just for funsies, we will get up, bring the VNC viewer up for 144. Yes, I trust the host. I don't know why. And then that's what it looks like when it first boots up. What I did prior to this, to showing you, is I went into Raspberry Pi configuration here and chose that I wanted a VNC in addition to SSH interface. SSH was already selected, of course. So let's return to our presentation and see what our next step is. We want to use Rasppi config in the CLI to set certain things. This is like a superset of what we just saw in the GUI as far as Raspberry Pi configuration. So let's go straight over there, and I will tell you what I'm doing before I do it, and then do it, then told you I did it. So we set HDMI sound. By default, sound will default to the headphone jack, which we don't want. There are built-in speakers in this screen, and they use HDMI sound, so we will want to set that up. The second thing is something I feel that I should probably show you rather than tell you about, and that means going back into VNC. We will bring up a web browser. And this caused me conniptions for quite some time. So I'm going to take my finger, I'm going to put it on the screen, and I'm going to attempt to scroll. And this is what happens. Instead, it's behaving, great, as though I had a mouse with the mouse button down and was scrolling. And I could not find a good way to handle that until I hit up on a certain thing just out of pure desperation that I want to show you. So let us go back to that, back to the terminal on the new demo Pi satellite machine, and say I want to do sudo raspi-config. And let me go into light mode so we can actually read this thing. So in system options, there are a couple things we want to do. The first would be that I had mentioned audio. So instead of headphones, we want to use the HDMI. And then additionally, you can find here also you can do various things that you can do. There's a bit of an overlap between Raspi config on the in the GUI and this, but this is much more comprehensive. And then advanced options. I was about to give up and switch to X11 off of Wayland simply to try things that I knew would work to make finger touch scrolling work. And when I went into here to do that, I discovered there are two window managers that you can use for Wayland. By default, this LabWC is chosen. If I choose Wayfire, voila, now touch scrolling will work. It will require a reboot, or at least a relog out and so forth. But that solved the options for that. So I'm going to reboot that device now, and we shall go back into dark mode, and we shall also go back into the test to see if the freaking scrolling now works. All right, it has rebooted, so we should be able to reattach on VNC. There we go. Let's try that same experiment again. I'll bring up the web browser. I'm just using keyboard. I'm just using mouse right now. Let's go to raspberrypi.com. I'm going to reach over to the screen and it scrolls. Now I'm sure with the LabWC window manager, the one that comes by default, there's a way to configure it so that it will do this across the board too. I don't want it just in a browser. I want it across the board. We've got the basics set up, so let's get down to business. We're going to pull down one single repository called Wyoming Satellite, and the other thing that must run on the satellite device, which is the local wakeword detection, we will do from this project, which is a wonderful thing. So to do that, I'm going to set up a certain directory structure. I like to create a /data home assistant and put that into the permissions of my unprivileged user. And then we will pull down the GitHub repo into that directory. So let's do that. This is going to be a little bit harder to follow maybe, but I'm going to grab the make directory command. I'm going to sudo change ownit. Now I'll just use my script here. And then we will go over to that directory, make sure it is owned by the Greg J user. And then we're going to clone that repository into our current directory. All right, we have it. There is more in the doc, but rather than following along in that, we'll review it after we've done it. So let's move into the cloned directory. And the first thing you do, the README will tell you here, the first thing you do is run script setup. What the script does is it will create a local Python environment just in this directory that will load up all the things that are needed to run the satellite. And that includes the Wyoming protocol itself and a bunch of other things that have to do with sound and controlling the microphone. All right. All right, now there is actually one additional component that I should probably put in this section that I like to do, which is we're going to set up one more thing that allows the satellite software to adjust noise suppression and microphone gain simply by configuration. So let's do that now as well. And that one's real quick. And then we have the marvelous feature that this project has given us and so many people have contributed to, which allows the rest of this installation to be easy. And many of the things that I was banging my head against the desk trying to figure out regarding sound and some other things are all handled by this simple thing. You'll notice there is a docs directory here. And let's say one of the tutorials is called installer.md. If you follow these instructions, you've got a way to set up all the rest of it very beautifully and easily. So we're going to do that. I have the relevant information in my document itself, which is in this portion. Use the installer to set up the satellite type, the microphone, the speakers, the Wakeword detection, everything you need. But what we're going to do is just go ahead and do that. So it's Python-m installer is how you get it going. And again, switch to light mode so we can read this thing. The first menu is satellite. Satellite name is good. Let's do, I was going to replace the kitchen satellite here. So let's do that. Satellite type is local Wakeword detection. There's no, okay, we're not doing respeaker here. And so let's go back. Let's do microphone. Auto detect. I am now going to speak loudly into the microphone so you know exactly whether or not you've got the right one. And will it come back? Yes. It's successfully detected the microphone. This is an ALSA device. It's going down to kind of at that lowest level of sound, even though we also have elements of pipe wire and pulse audio above those things. So let's do that. And then audio settings. Do we want noise suppression? Yes. False positives are a big problem with the Wakewords at times. And then auto gain, it says in the document to choose 10. I found that to be oversaturated for my usage in this particular device. So it says 15 rather, so I choose 10. And then back, and then we'll do speakers. Play sound, well, there's no speaker device, so let's test. Play a sound, I hear nothing. Next device, nothing. Next device, nothing. Next device, there we go. So we will choose that device. And then this last one is really, really cool. You don't want to do without it. Choose on wake up and after voice command. In this way, the satellite will play a sound as soon as the wake word has been detected, so that you know that it's been detected, and then as soon as your voice command has been recognized. So basically, you begin speaking, you say, turn off the kitchen or whatever it is, and then that will indicate that has been detected. The audio is being sent through the rest of the pipeline, and you're good to go. Okay, and then finally the wake word. The wake word system is, whoops, not that. Boy, I hope everything else is still in there. Yes, okay. It just kind of crashed right out of there. So don't do that. Let's choose Wakeword. Our Wakeword system is actually Open Wakeword. Yes, let's install it. That's that other Wyoming Open Wakeword project that this will actually download and configure for us. And it's doing all of that right now. The % scroll bar is completely meaningless. It just goes round and round and round until the whole process is finished. So we'll wait for that. What else do we need to know here? We're almost done. This is way easier than it should be thanks to this Python installer script. All right, now we want to choose our wake word. The ones that are provided in this project out of the box, I would highly recommend using one of them rather than just going straight out to download a community wake word such as GLaDOS or Wheatley or whatever else it might be. There are many, many of them, but they are not trained as well against false positives. So for instance, with the GLaDOS wake word, I would literally be in the room. No one was speaking, no music was playing, no nothing, and it would trigger. So it literally says in the README file for that wake word, for example, that there will be 6 false positives triggered per hour. So I'm going to have to look into some options to change that. For now, I am in fact using OKNabu. But you can also download community wake words. We might as well do that because you'll want to play with them despite the false positives. And you can play with various settings here as well with them. But anyway, we're going to stick with Open or OKNabu. I'm sorry, I'm having problems with the trying to use keys that won't work in here. Okay, we're sticking with OKNabu, but as you can see, there are many to choose from and to at least play with. And then we're going to apply the settings, which will require sudo because it's installing services, systemd services, and it's installing root level systemd services for the wake word detection and the Wyoming Satellite. And at this point, we are done. We have installed these things. We have done all of these things that this portion says, and we can look at our logs using systemd commands to look at the logs. In fact, I might as well actually do that just so you see what it looks like. And so it says ready and connected to services, but it's not really ready because the next part in our process is that we need to let Home Assistant know of this new satellite. So to do that, we'll go back to Home Assistant settings. Let's go to devices and services and choose Wyoming protocol. Oh, well, this is unusual. Usually I don't see it auto-detecting that a new satellite has come online, but in this case it has. So let's simply add it. And the area is not really, but supposedly kitchen. And we will finish that. All right. I do want to show also what it looks like when that doesn't happen. You would say, basically, I'm sorry, you would add a service and not one of the discovered ones. So I would put in my 144 and I would put in port 10700. That's what it automatically detected already, but that's all you have to do to set it up if it doesn't detect it. So it's pretty great. And then what's our next step? Let's see. Oh, let's try it. Okay, Nabu, what project are you currently working on?
I'm currently working on my lifelong project, managing the chaos caused by your every action. It's a full-time commitment.
Is that wonderful? Who does not want GLaDOS as their home assistant? So we are done. It was remarkably quick, especially if you're not having to explain it all. It's really quick to set up. You can do it in half an hour if things don't go all pear-shaped on you. So with that, what things could go pear-shaped? Let's jump into problems and solutions, and I'm going to show you the final thing of what it looks like when even more things are configured. I think you're going to want to either stick around to the end or just skip to the last section. All right, so if Home Assistant doesn't see the Wyoming Satellite port, for instance, this could happen if you're installing it on any other kind of device, with any other kind of OS, like an old laptop or something, then you need to look for the ports. So I include how you do that to make sure that port 10700 is in fact on an interface that can be seen outside of that device. And then possibly open up firewall to allow that port 700. For instance, on Ubuntu, you're almost always having to do that. So you would say UFW allow 10700. And then looking at the logs, this is how you do it. If the touchscreen drags instead of scrolling, we already saw that and we know how to fix it. We know one way to fix it at least. And then sound doesn't always go well. So learning commands that are used for ALSA is very important. And that's way beyond the scope of this. So I just want to mention it, but look for those things. And then if you've got, you're going to want to be running your Home Assistant page as full screen on the device. And then you won't have a keyboard to it. So, there are various tricks such as enabling VNC, enabling SSH, and then maybe even attaching an external keyboard while you get it all set up. And then there's from the hacks, which is Home Assistant Community something. If you use that on your Home Assistant, you can install Browser Control Card, which is also very handy with that. I found, let's go back to VNC. Basically, it says if you want to get out of full screen, press escape. That's no good if you have no keyboard. However, I have found that if you press at the top of the screen for an extended time, it will either select text or it will give you a menu that includes the option to allow you to exit full screen. So that's very helpful too. So just wanted to mention that. And then to start the browser full screen, I have a little script that is placed in auto start to kill all versions of all instances of Chromium that are currently running, and then to set the display equal to the display of the screen here, and then run Chromium browser, start maximize, start full screen. One or the other of those actually does what I want it to, and then to run the Home Assistant that I have in the background. And then once you're on there on the device, you can set set the Home Assistant default to dark mode, set a default dashboard, hide the sidebar, and all those things that make it look nicest on the screen. All right, and then setting up notifications using Dunster Similar is useful and amusing, which you will see at the very end. And then if you encounter a Wi-Fi issue where the Wi-Fi is absolutely crawling whenever it accesses the internet, such as doing a sudo apt update, then there's a fix for that in the document as well. It's basically, I think it's no longer a problem, but there was an over aggressive power saving function on the Wi-Fi previously. And then finally, one thing I do is I kind of reconfigure the services that were already set up to run as user services, because I just find that more peaceful to my mind and easier to deal with when I'm changing things, and things like the commands that go in the Wyoming Satellite. As you see, there's a lot of options, and I want these to be pretty dynamic. So I just like using the system control user options that don't require sudo for that. Okay, and then finally, I'm going to reboot into the card that had been loaded before and show you what you can do with all of those Wyoming Satellite options, just as an amusing thing. And so you get a good idea of why you really want this. All right, come back in just a moment. And we now have, this is what currently things look like when it comes up. The one thing I want to show you is additional thing you can do with the satellite. Let's say, okay, Nabu, could you please turn on the bar light?
The bar switch light is now on. Enjoy your sophisticated evening at the dimly lit bar.
How nice is that? So I mentioned before that you might want to put it on Dunst or any other notification service because the satellite service also allows you to run scripts at all kinds of different events in the process of listening for the wake word and getting the voice and getting the response and all those things. So I hope you enjoyed this. All of that, although we didn't go into it on the hands-on section, but it is in the script in the GitHub project and my GitHub project. And so I hope you enjoyed it. If you did, please like and subscribe. Again, I'm not a real YouTuber. I only play one on YouTube. It doesn't make me money, but I sure do love it. And I love the interaction and would like to know what you'd like to see next. Later.